Good morning, everyone. I'm Uma Maheshwari, Assistant Professor from the Department of Electronics and Communication Engineering. In this particular video lecture series, I'm going to explain about a comparison of a various pulse communication techniques. We'll be having a pulse amplitude modulation, pulse width modulation, and a pulse position modulation. And first, we'll be seeing about a pulse amplitude modulation. Here, by varying the amplitude of the pulses in proportion to the instantaneous value of the analog signal, that is, by varying the carrier signal in proportion with the pulse of the amplitude varies in accordance with the pulse of the message signal, uh, where the pulse amplitude modulation is used in a popular Ethernet communication standard. Here, the pulse amplitude modulation is shown in the analog signal for modulating. Then the next one is a carrier pulse is displayed here, and finally, while mixing those, will be getting a pulse amplitude modulation in positive cycle where the waves will be at the top, and in this negative cycle it will be in the negative part. Pulse width modulation, by varying the width of the pulses in proportion to the instantaneous value of the message signal. That is, the width of the pulses varies but the amplitude of the pulse remains constant. Amplitude limiters are used to make the amplitude constant. Here, this is the carrier pulse. The next one is a modulating signal as shown, where the width of the pulse varies is shown here. But in the first one, the width of the first pulse is varied. In next one is the second, and the third width is changed, increased, reduced, and then increased. Then the pulse position modulation, by varying the position of the pulses in proportion to the instantaneous value of the analog signal. The pulse position modulation is done in accordance with the pulse width modulated signal. Each trailing of the pulse width modulated signal becomes the starting point for the pulses in the pulse position modulation. The pulse amplitude carrier wave, the pulse width here, where width of the pulse is shown where in this diagram, particularly where PAM, PWM and PPM signal is shown, where width is varied, then the position of the pulse is varied in the pulse position modulated wave. The various differences in of the pulse amplitude, pulse position and the pulse width modulation are the carrier, according to the carrier, in PAM will be having a train of pulses. In this three techniques will be having only the train of pulses. Then the characteristics of the various pulse carrier are: in amplitude will be having a amplitude, in width will be having width, and in the position will be having the position. The bandwidth requirement are low, high and high. Noise is also no, low, high and high. The information contained is: amplitude varies in PAM, width varies in PWM, position varies in PPM. Then the power efficiency, that is signal to noise ratio, are low, moderate and high. The transmitted power varies with respect to the amplitude of the pulses. Then width varies with respect to pulse width modulation, and in ppm it remains constant. Then for the transmitting pulses, in PAM PWM it is not needed, but in pulse position it is needed. The bandwidth depends on the width of the pulse in PAM. Bandwidth depends on the rise time of the pulse, and the same in ppm also, it depends on the rise time of the pulse, where the transmitter power varies with respect to amplitude of a pulses in PAM, amplitude and width of the pulses in PWM. Here the width of the pulses remains constant. It is similar to AM, FM and PM. That is the main difference. The main key differences between these are: the amplitude shows proportionality with the amplitude of the modulating signal. In PWM, the width of the pulses shows proportionality with the amplitude of the message signal. Whereas in ppm, the position of the pulses is proportional to the amplitude of the analog modulating signal. Then in PAM technique, it shows low immunity towards the noise as against PWM and PPM, it has low noise interference factor because the noise immunity is very high. These are the assessment where differentiate the types of a pulse modulation and what is meant by the transmitted and the transmitted power. Then define power efficiency. Thank you.